Welcome to this class. This session, we are going to demonstrate how to evaluate an integral using Cauchy's theorem or Cauchy's formula. So evaluate the integral five z divided by z plus 1 raised power 6 dz where C is the circles so 1, this is the first circle, part B or part 2, this is the circle, and part 3 this simply means a circle of radius 3 units centered at the origin, circle of radius 1 unit centered at the origin, this circle of radius 0.5 units centered at the origin. So to evaluate this integral, we remember the Cauchy integral formula for derivatives. Solution. We know that the value of the nth derivative of the function at a point A is n factorial over 2 pi I integral of f of z divided by z minus a raised power n plus 1 dz. So this is the integration formula by Cauchy. So we have to identify our n and identify our a in order to solve the problem at hand. So from this formula, you can deduce that when you have the integral along a curve C, f of z, z minus a power n plus 1 dz is simply the same as, so multiply both sides by 2 pi I and then divide by n factorial and then the nth derivative of the function at this point z equals to a. So we know the value of a and we know the value of n, we should be able to solve such an integral. Now our problem is to integrate f of z, which is given by e raised power 5z over z plus 1 power 6 dz. Now, so that it takes the same standard form, we can say this is the same as integral along C e raised power 5z divided by, I write z minus 1 and then n plus 1. So 6 can be written as 5 plus 1 and then dz. So clearly, our n is 5 and our a is -1. So which means that then the integral of 5 e raised to power 5z over z plus 1 power 6 dz will be the same as 2 pi I over 5 factorial, because that's the value of n factorial, and then the fifth derivative of the function at the point -1. So we need to calculate the fifth derivative of the function. So remember here, the f of z is this part here, e raised power 5z. And we know 5 factorial is 120. So it's like we have our value is, so 2 over 120 is just pi I over 120. So 120, 2 divided by 120, so this 60. Fifth derivative of the function at -1. But then each case, the three problems we have will be handled according to whether the point is within the circle specified, the point z equals to -1 is within the circle or outside the circle. So f of z equals to e raised power 5z, then first derivative, use chain rule, differentiate this part to get 5 to multiply by the function. And then the second derivative of the function, differentiate this one again, so 25 e raised power 5z. Then the third derivative, also differentiate this power and pre-multiply, so we get 125 e raised power 5z. And then fourth derivative of the function, you get 5 times 125, 625 e raised power 5z. And then the fifth derivative, the last one, multiply that answer by 5, get that 125 e raised power 5z. So when the formula tells us fifth derivative at -1, simply means where the z put -1, we have that 125 e raised power -1 by 5 is -5, so that the fifth derivative at -1 is 3125 over e raised power 5. Thus, before specifying the specific circle or the specific curve, the value of this integral should take the form pi I over 60 times 3125 over e raised power 5. Which is given by 625 over 12 e power 5 pi I. But then this is a general one. Now, this is a correct value depending on whether the point z equals to -1 is within or on the circle or outside the circle specified. So for part 1, if they specify that z, the curve C is the circle given by radius. Remember, the first value of n is first value of this radius is 3. So when you say the circle of radius 3, this means that if this is the plane, then this is -3, -2, -1, 0, 1, 2, then 3. So, and the point A, z equals to A, our case was z equals to -1. So -1 is a point, clearly you can see that -1 is a point within this circle of radius 3 whose center is the origin. So therefore, the formula applies. So therefore, the integral of e raised power 5z over z plus 1 power 6 dz is equals to 625 over 12 e raised power 5 pi I. Then the second circle was the circle was given by circle centered at the origin, radius 1. So if you draw that circle, so this is -1, so this will be +1. So this is the origin. Now, our point z is z equals to -1. So this is this is the a value. Remember the formula, this Cauchy formula for integration works when this formula is always true if the point z equals to a is inside or on the circle C or the curve C. Now, because our point is z equals to -1, and if you draw a circle of radius 1, that point is on that circle, then therefore the formula holds the way it is. So still the integral along C, e raised power C, which is a circle radius 1, C, which is a circle radius 3, e raised power 5z divided by z plus 1 power 6 dz will still have the same value, 625 over 12 e raised power 5 pi I. And then last one, number 3, circle whose radius is 0.5. So e raised power 5z over z plus 1 power 6 dz. Now, if you sketch so if this is the 0, then this should be 0.5, and then this should be minus 0.5. So remember, our point for this problem is z equals to -1. So if you try to plot that point z equals to -1, it will be a point somewhere here, which is outside the circle of radius 0 or 0.5 units. So whenever the point z equals to a is outside the circle specified for C, then the integral is taken to be 0. So that's the difference on how you need to interpret where the curve C or where the integration is taking place. So this has an effect on how the value of the integral will be. When the value is on the curve or inside the curve, then the formula works the way it is. If the value is outside the curve, then the value of the integral is taken to be 0. So thank you.